Once again, welcome back to Advanced Hypothesis Testing. Today we are going to discuss the Advanced Hypothesis Testing. Okay, so first we have to study what is the dependent sample and independent samples. Okay, so the name itself reveals what is a dependent sample and independent sample. The hypothesis test involves the dependent samples if there is a pairing between the samples, such as with the before and after, husband and wife, identical twin studies, like that way. So there is a dependence between the samples. Then we can say, if we discuss the samples of husbands and wife, then the identical twins, just like that way. So each individual member of the first sample corresponds to the specified individual member of the second sample. So just if we have two samples, say like this way, this is X and Y. The first sample, say if it is say A related to say alpha, B related to say beta, like that way. So it's the first one means the set of samples of husbands, and second one is the samples of wives. So that's mean they are mutually dependent. So that's why they are connected. So such samples are called dependent samples. Okay. So that's why each individual member of the first sample corresponds to a specified individual member of the second sample. That's why they are known as the dependent samples. Then if they are not, there is no relationship between them, then it is called independent samples. I think that makes sense. Okay. And this will give you a clear picture of the things again. If you have, you choose one sample has no effect on the way you choose the other sample, then the samples are independent. If there is no connection between the first sample and that means they are independent. Let's say we can think about the thing in other way. The individuals from one sample are overall different from the individuals from the other sample. So that means they are independent. Okay. That means the sample 1 has no effect on the sample 2, then they are said to be independent. And if they are paired like that way, then we call this if one sample is paired with a mesh from the other sample, then we call they are dependent or matched pairs or paired. Okay. So that means if there is a relationship, if there is a connection between the samples, then it is a dependent sample. And if there is no connection between the sample, then we call they are independent samples. Okay. Now let us have some examples. For the first one, here is an example for that one. For each scenario listed below, determine whether the scenario represents an independent samples or dependent samples. Or dependent means or matched pairs. Okay. Okay. So first one, comparing the daily high temperature in Los Angeles and San Diego for each day of the summer. Say, in each day of the summer, the temperature, the Los Angeles and San Diego are the two different states, means two different places in the United States of America. So almost all the states have the similar scenario in the summer season. So that's why in the same day, the temperature are connected. Means if the temperature of one place here in US means in some place in Los Angeles is high in the summer day, then the same effect will be high in the San Diego also. That means they are connected. That means they are matched pairs or they are dependent, right? So that's the meaning of that one. So they are matched pairs. Okay. Moving on to the second one, B. Comparing the number of times 50 students in California and 50 students in Texas are ate out in a restaurant last year. So what do you think about that one? The 50 students in Texas and 50 students in California, say they're ate out in a restaurant last year. So that so we can't say find any connection between the students, because the students are living in different areas and they have different say features, and so we cannot find any connection between the students ate out of a restaurant in different parts of the country. So that means they are independent, so they are not matched pairs, or they are there is no connection between these two, right? Okay. And then moving on to this third one, comparing revenue at a bike shop in March and September. Say it's the revenue of a bike shop. So in March and September. So in March and September, you know, March is in the spring season, and September is on fall season. Therefore, there can be varied, right? The revenue at a bike shop, even if it is in the same bike shop, it's the climate changes, so that may affect badly, and one may affect, say, a favor of that one. So there are different, say, seasons, or different seasons have different scenarios. So that's why there is no connection between the revenue of the bike selling in a fall season and a spring season. So that is independent. Okay. And similarly, in the next one, comparing the calories consumed by 50 people for breakfast and for dinner. So the same 50 people, so the calories consumed, they have the same eating habit, and so they have the same people. So that means they are the breakfast and dinner. So that may be connected. So that means they are paired. So because we are discussing about the same 50 people, so they have the same scenarios, they can be connected. So that's why they are dependent or a matched pair. Okay. Okay. Then let us have another example. That is, say, comparing. So we have given 4 conditions, and we have to check whether they are matched pairs or independent pairs. Okay. So let's the first one. Comparing the pre-test scores before training to post-test scores. Okay. So, you know, before the pre-test means pre-test score and the post-test scores are correlated, because, you know, after training and before, after training and before training means, so they are compared. So they will be dependent. So, you know, when the pre-test score will automatically increase, say, after the training. Okay, so the post-test score will be, say, almost the same way. If all the students have the same effect on that one, so they can be comparable. So that means they are matched pairs. Okay. Now, second one. Comparing the number of speeding tickets received by men to the number received by the women. So that are, you know, that are independent, because the men's and women are different driving patterns and different scenarios. So that they are not dependent. That means they are not matched pairs. So that means they are not matched pairs. Okay. Okay. Now the third one. Comparing pain levels before and after treatment with magnetic therapy. So, you know, there is a connection between the pain levels before and after. If you compare the pain level before the therapy and after therapy, that will be correlated. That will be dependent. It means they are dependent. So if it is after the therapy, it will automatically reduce. That is the secret of treatment, right? So that are automatically matched pairs, right? Okay, so that is the third one. And then fourth one, comparing pain levels of a group receiving placebo to a group receiving medicines. Yeah, you know, they are independent, because, you know, there is no connection between that way. So that's why they are not matched pairs. Okay. So that's all about the dependent and independent variables. That means dependent, if they are dependent, one sample is correlated to other sample, then they are said to be correlated, or they are said to be the dependents, okay, or matched pairs. And if there is no connection between the variables, then automatically we will call they are independent. That's all about that one. Okay. Now we are going to discuss hypothesis test for 2 population proportions. So far we have discussed the hypothesis test for only 1 population proportion. And the same thing for the normal distribution also, we will discuss that. But first we are going to discuss the population proportions first. Okay, so to have two population proportions. Let x1 be the number of successes from the group 1 and x2 be the number of successes from the group 2. So we have two proportions. One is, we can call it as the two samples. One is x and the x1 and the other is x2. So the number of successes from the first one is taken as x1 and that of the second one is taken as the x2. And a success rate, that is that one. Then the P is the mean for that one. So the P1 be the mean of the first one and P2 be the mean of the second one. Then the null and alternative hypothesis. So there are two types of tests. You know, there are two types of tests. One is the two-tailed test. That means P1 equal to P2 or P1 not equal to P2. So that means that are the two two-tailed test, and that is P1 less than P2, that is left-tailed test, and P1 greater than P2, that is the right-tailed test. Okay, so and that is the alternative hypothesis, and always the null hypothesis is P1 is equal to P2. So we assume the mean of the first one is equal to mean of the second one, and that is the null hypothesis. We always take the null hypothesis as P1 is equal to P2. Or we can say P1, if P1 is equal to P2, you know, P1 is equal to P2 means you can write it as P1 minus P2 equal to 0. So that's why either we can write in this form or we can write this form. That is the null hypothesis. Then if P1 less than P2, the same way, P1 less than P2, that is the alternative hypothesis. The alternative hypothesis can be either be in P1 less than P2, then P1 minus P2 will be, we know, that will be less than 0. That is this one. If we took this as P1 greater than P2, then P1 minus P2 should be greater than 0. That is the second one. And if P1 is equal to P2, if we take P1 is equal to P2, then P1 minus P2 is equal to 0. So if P1 is not, this is the null hypothesis, and if the alternative hypothesis is taken as P1 not equal to P2, then P1 minus P2 not equal to 0. That is the null and alternative hypothesis. But always we took the null hypothesis as this one, H0, P1 is equal to P2 or P1 minus P2 is equal to 0. Okay. Now, check the assumptions for a hypothesis test. A simple random sample size N1 is taken from the first population and that of N2 is taken from the second population. So we have two populations having N, and we took a sample N1 from first population and a sample N2 from the second population. Then the samples are independent. They are not paired ones, so that is, they are independent. Then the assumption for that one is the binomial distribution satisfied for both the populations. And then find the P1 for the first one and P2 for the second one, means the mean for the first one and P2 for the next one. You know how to find P1. P1 cap is equal to x1 over n1, x1 over n1. And P2 is the mean for the second one, that is x2 over n2. Okay, number of successes, total number of samples, number of successes, total number of samples. Yeah. And Q1, you know how to find Q1. Q1 means Q1 is equal to 1 minus P1 and Q2 is equal to 1 minus P2. Okay. Okay. So, so we need to show that, to determine the sampling distribution, we need to show that the product should be N1 P1 should be greater than or equal to 5 and N1 Q1 is also greater than or equal to 5. And similarly, the same thing for this one. Then only we can do the sampling distribution, the hypothesis test for the sampling distributions. Okay. So, these are some requirements to test the hypothesis. One is two samples, they are independent. Then the NP means the mean value. So N1 P1 should be greater than or equal to 5 and N1 Q1 is also greater than or equal to 5. And the same thing for the N to P2 and N to Q2. Okay. Now we are going to find out this test statistics for the two proportions. So we have already know how to find the test statistics and the probability for the single sample, but now we are going to discuss how to do that one for the two proportions. Okay, so for that we have to first find P1. As I mentioned earlier, we have to find P1 over P1 cap is x1 over n1 and P2 cap is x2 over n2. Okay, then we want to club that. We want to say pool that two samples together. Means x1, n1 size sample is first one, and n2 is the second sample, and we take the successor from n1 as x1 and the success from n2 as x2, and then we club that together. Then we get a pooled sample, and that is called a pooled sample. And if you get a pooled sample, we want to find the probability of the pooled sample. And then the probability of the pooled sample is denoted by P bar and is given by x1 plus x2 divided by n1 plus n2. We add all when the pooled data, we have to add that number of successors and add the number of total number of things. So, and we can find the Q bar as 1 minus P bar. Okay, so P bar is called the probability of the P value for the pooled data when we club that together and the total number together. And of course, Q bar is equal to 1 minus P bar. Then the test statistics is given by this one. So we know if we have only one, then we have Z is equal to, P cap minus P divided by square root of PQ over N. So, but we have two, so we will take it as P1, the pool data. So P1 cap minus P2 cap minus P1 minus P2 divided by first one square root of P1 Q1 divided by N1 plus P2 Q2 divided by N2. Of course, these are the pooled data. Okay. Okay. So usually we took the null hypothesis as P1 equal to P2, so this will be always be 0. So in generally, we can say this is the test statistics and P1 minus P2, P1 cap minus P2 cap. So just change this one as P1 minus P2 and this one is always 0. Then P1 Q1 over N1 plus P2 Q2 over N2 square root of. Okay. Now the things will be more clear when we do some problems. Okay. And now, if again the p-value, the probability of that is the test statistics, and when we find the probability p-value, if the p-value is less than alpha, we will reject, and if the p-value is greater than or equal to alpha, we will accept, means fail to reject the null hypothesis. That's the thing, the same as in the previous case. And if you want to find the confidence interval for the difference between the two population proportion, then the same thing. Though, so we first want to find out the P1 value, x1 over n1, P2 cap, x2 over n2. And then the confidence interval will be error. First we have to find EBP. EBP is equal to Z alpha by 2 into square root of, we know the first one. If it is a single one, we take the EBP is equal to Z alpha by 2 into square root of PQ divided by N. And if we have two data, we will add that together. P1 Q1 by N1 plus P2 Q2 by N2. So that's it. And that is what is the EBP. And once you got the EBP, you can subtract that from the mean value. So this is the confidence interval for that one. Okay. So definitely we are going to use the GeoGebra to find out the population test statistics and the p-value and the confidence interval also. Okay, so we can find out that using GeoGebra. So that's the way in which we are calculating this one. So just try to focus on how to find the test statistics. So going back to test statistics, it is P1 minus P2, P1 cap minus P2 cap minus P1 minus P2 divided by square root of PQ over N1 plus PQ over N2. Okay, and then if the P value is greater than alpha, we will accept, means fail to reject, and if P value is less than alpha, we will reject the hypothesis. Okay, and then the confidence interval also. To find the confidence interval, we need to find the EBP, error bound proportion. So that is given by Z alpha by 2 into square root of P1 Q1 divided by N1 plus P2 Q2 divided by N2. And then the error, once you got the error, you can subtract that one from the mean and add that to the mean, you will get the confidence interval. That's it. Okay. So I think that makes sense, and we can do the problems in the next video. That will be more helpful. Okay. So see you with the problems in the next video. Till then, goodbye.